Hello, everyone. I'm here to talk to you about the abalone dataset. This code is meant to provide a way to accurately measure an abalone's age by using its physical characteristics, making the abalone farming and harvesting more efficient. We first start by pre-processing the abalone dataset. First, we imported external libraries to help with our exploratory data analysis. Scikit learning libraries were imported for pre-processing, model training, and evaluation in order to be consistent across all our regression models. We then import the abalone dataset and separate the rings column from the rest to identify our target variable. At the beginning of our exploratory data analysis, we check for missing values and duplicates, as well as look at the size and data types of and within our dataset. We used AutoVis to create some graphs to help us better understand the data and draw correlations. One of the graphs was a heat map showing the relationship between our numerical variables, and from this, we learned that the rings did not have a strong correlation with any single variable. We then changed the sex column into numbers to be able to run in the regression model and check the skew of all the columns in order to determine whether or not there are values that need to be dropped so that linear regression is not overly influenced by outliers. We then use a version of Tukey's rules where we multiply the interquartile range by a factor of 2 and drop any rows containing numbers which are that value away from the median. After separating the data into training and test set using an 80-20 split, we scaled the data in both sets to ensure that no variables were getting lost in the noise, as well as to standardize all the data from the test set to the training set and the predictors to the target variable. We then used a random forest regressor and matplotlib to plot a bar chart showing the importance of each predictor variable. We evaluated the model based on the mean squared error, mean absolute error, and R squared values. And finally, we used 8 different regression models plotting the predicted versus actual values and calculating maximum error for each in order to find the best model. Well, being one of the better models, multiple linear regression did not have a good fit, indicated by the R squared value of 0.53, and without manually creating polynomials, it is not a very complex model. Logistic regression was not ideal for this data set because we were looking to accurately define the age of abalones without having to separate it into groups like young and old. The decision tree was chosen because it is effective in comparing the relationship between variables, but it had a hard fit with a higher mean squared error and mean absolute error values, as well as an R squared of 21.21. Multiple linear regression exhibits high bias, oversimplifying the relationship between the data, leading to underfitting. The decision tree was on the other end of the spectrum, showing high variance and becoming overly sensitive. We used the ridge model to try and balance bias versus variance, but it ended up almost exactly identical to our multiple linear regression, the main difference being a 0.02% lower maximum error. All in all, more work is necessary in order to find a model suitable to replace manually counting the rings for each abalone. Thank you.